Chapter 1, Section 8. We've skipped a few sections. Our main objective today is to get ready for word problems, but not do word problems yet. We're going to translate words into symbols. So that's our main objective for today. And we're going to practice that with each of the equivalent expressions below. So example 1, we're going to take each phrase in English and replace it with an equivalent algebraic expression. Remember, an expression is not an equation, so we're not looking for equal signs. To keep things simple, we're going to use x as the variable for all of these. So example 1a, the number is going to be represented by x. Decreased by, if we recall from Algebra 1, that's representing the operation of subtraction. So far it's x minus, and then the quantity here that we're subtracting is 10. So x minus 10 is our expression. As I said, we're starting out fairly simple here. 7, so that's our number. More than refers to the idea of addition. And then 5 times, that's multiplication by 5 of the number 5x. Now, literally, when you see the more than, it means the then says change the order of the way it's written. So we're going to start out with 5 times the number, or 5x, and then we're going to add to it the 7. So my expression is 5x plus 7. So when you see the word then, and more than and less than, that means change the order of what's written in the original expression. All right, example 1c, the difference between a number and its cube. Difference means subtract. The number, we're going to use x as the variable for the number, and its cube, that's going to be x cubed, and we just keep the order the same, so that's x, the number. Here's the difference between the number and the number, its cube. Okay, x minus x cubed. 1d, we've got the sum, and that means addition, of double the number, so that's 2 times x, and then 8. Now in this case, and we're going to compare this one to the next one, 1e, to see how they're different. But double the number, the sum of that, and 8. So double the number of x is 2x, and then the sum of that with 8 is 2x plus 8. As I said, we need to compare that one, 1d, with 1e. So this one says twice the sum of a number and 8. See how we've got sum and double and twice and sum. Twice means double it, but the order is different. And that's going to change the meaning altogether. We want to start with the sum of the number and 8 first, and then we want to double that or take twice that. So that means we need parentheses. The number x plus 8, parentheses multiplied by 2. Now don't forget that these two answers are different. 2x plus 8. This one, after the distributive property, is 2x plus 16. So slight difference in the words, big difference in the expression and in the meaning on that one. Excuse me. Let's look at some more expressions in example 2. Joe is driving his car at x miles per hour. So he's driving at x miles per hour. Use the variable. We're going to use the variable x to represent each phrase below with an algebraic expression. So we're not really doing the entire word problem yet. We're just doing expressions for each portion of this. What's Joe's speed if he drives 5 miles per hour slower? Well, x is going to represent his speed. In this case, the slower is going to give us the subtraction. So it's Joe's current speed x minus 5 miles an hour. That's 5 miles an hour slower. So we're taking 5 miles an hour off of what his speed was. All right, we want Joe's speed if he drives 10 miles an hour faster. Well, x is the speed Joe was driving, but after he speeds up, it's going to be x plus 10. Just like before, x was what he was driving, and then 5 miles an hour slower was x minus 5, and then faster, x plus 10. Really easy so far. The average. Now remember, average involves two operations. Average means add together all the numbers there are and divide by how many numbers there are. So let's read the problem and see how many numbers there are. Joe's speed and Judy's speed if Judy drives at 55. Now Joe's speed, we were using x to represent Joe's speed. So we want to take Joe's speed x, add it to Judy's speed, 55. We want the average of that. So when we add x plus 55, we need the parentheses to make sure we do the addition first, and then we're going to divide by 2 to get the average. So x plus 55, that quantity in parentheses divided by 2. All right, let's look at a few more. These are going to be a little reminder from geometry. So let's see what we can remember about the base of an isosceles triangle. It has a length of b inches, and each base angle measures a degrees. Now it might be helpful if we had a diagram, and pictures are worth those 1,000 words. So let's see, isosceles triangle, remember, means that two sides are congruent, meaning the same length. And remember that the angles opposite those two sides are also congruent. And here's my base side B. Now let's try to find out what they want us to represent. Let's find the measure of the vertex angle, that would be this angle at the top, in terms of A. Well, this angle is A degrees, that angle is A degrees. We want to find this one. And what we do know is that all three angles of a triangle add up to 180. So to find this missing angle, yep, you're right, we're going to take 180 minus the other two angles. So 180 minus A plus A, or 180 minus 2 of those A, and that is my decimal, not my decimal, sorry, my degree for the angle of my vertex. Okay, 180 minus the 2A. All right, let's look at example 3b. We've got a perimeter of 240 inches. Find the length of one of the legs in terms of b. So if we add all three sides together of this triangle, that's what perimeter means. Literally, peri is around and meter is to measure. So we're going to measure the distance all the way around. And for that, we know that 240 is the length of all three sides. I don't know the length of these two congruent sides. Let's just call it S for side of a triangle. That makes sense. So it's 1S plus another S plus B for the base. And let's just go ahead and simplify that. S plus S is 2S. And what they want to know in terms of B, so that means get B by itself. So one of the things I want to do is I want to get the 2s over on the other side, or actually I'm flipping things around here. We're going to subtract b from both sides. 240 minus b is 240 minus b. And then to find out what s is in terms of b, I need to divide everything in this equation by 2. 2s divided by 2 is 1s. 240 divided by 2 is 120. B divided by 2 is a half of b. And that is the measure of side A in terms of B. So we had to isolate the S variable. So in this equation, got to get the 2S by itself, subtract the B from the 240, and then I also changed both sides of the equation, those two steps in one. All right, let's look at a distance problem. We're not going to do the whole thing. We're just going to set up some of the expressions for it. But let's go ahead whenever we have distance and do a chart. Distance equals rate times time. And as we read this, we got a truck that's leaving some city, USA at noon, drove south at 55. An hour later, a car left some city driving north at 65. How far apart is the car from the truck? X hours after noon. And then write our answer in terms of X. So to fill in our chart, we have to represent the truck and the car. Now let's start filling in what we know. We know that the truck right here was driving at 55 miles an hour. So in the row representing the truck's information, the rate is 55. We know the car, it tells us, is traveling at 65 miles per hour. So for the car row, under the rate column, let's put in 65. Now, we need to read the problem to try to find some more information. I don't know how much time the truck was driving. It just said it left at noon. And we're comparing when the car left to the truck. It was an hour later. I have no idea what time, how much time the truck is going to be driving, so we're going to call that X. But since we're comparing the car to the truck left an hour later, so the amount of time the car is going to drive is 1 hour less than the amount of time the truck was driving. So if T we could use T, or in this case X, since they said to use X. Normally I would use T for time, so it's not confusing. But X is going to represent the truck. The car is driving faster, so it takes them an hour less. All right, how about this distance column? How do we fill that in? Well, fortunately, we know a formula. Distance equals rate times time. So to find the distance, I'll take the rate 55 times the time X. 55 times X is the distance the truck travels. Likewise for the car, 65 times X minus 1. Distance equals rate times time. The distance the car travels is 65 times X minus 1. All right, we need to kind of put this together and find some information out. We need to know the total distance that these two were apart when they're done. Because one of them, the car, is driving north and the truck is driving south. So obviously they're in opposite directions, north and south. We're going to take the distance the truck drove, the distance the car drove, add the two together. Now I'm going to hide the words for a moment so we can look at the chart and our expression. And let's distribute out the 65. So that's 65x minus 65. Collect my like terms. 55x plus 65x is 120x minus the 65. I'm going to come back just for a moment and make sure I answered the question. It says, how far apart is it? X hours afternoon, express your answer in terms of X. Well, that's my representation, 120X minus 65. My answer is in terms of X. So we'll leave our distance problem at that. Another frequent thing we see in expressions and word problems is the consecutive number ideas. Consecutive numbers are numbers that come one right after each other. So for consecutive integers, it might be -3, -2, -1, 0, 1, 2, 3. And the little dots mean that pattern goes forever, infinity in either direction. In terms of variables then, we might start with n plus 1, n plus 2, n plus 3. On the other side of n minus 1, n minus 2, n minus 3. So whatever we start n out with, we're incrementing by 1, and we would say decrementing by 1 or subtracting 1 as we get smaller. When we talk about consecutive even integers, we might think of numbers like -6, -4, -2, 0, 2, 4, 6. So if we let n represent one of the numbers, we have to go to the next number. So from 0 to 2, I'm skipping over 2. So I need to take my original number and add 2 to it. I need to add 2 more to that to get my next number. So n plus 2 more is n plus 4. To go smaller, n minus 2. And then smaller than that, I got to subtract 2 more from n minus 2. That's n minus 4. And n represents here an even integer to start with. When you look at consecutive odds, it might look a little confusing. Because you're saying, wow, that's the exact same thing. But now I've got the odd integers, -5, -3, -1, 0, 1, 3, 5. How can that be? Well, it's all where our starting point reference is. N is starting out as an odd integer. To go from one odd integer to another, like from 1 to 3, because 0 is not odd, I just put that in there in the number line. That should actually be crossed out. So to go from 1 to 3, what we need to do is we need to increment by 2, so n plus 2. From 3 to 5, we need to increment by 2 more, so n plus 2 more is 4. And then to go in the other direction, n, to get to the odd number smaller, we're subtracting 2. So if we went from, let's just say, -1 to -3, we would have to subtract 2. And then from n, the next smaller, we'd subtract 2 more, n minus 2 minus 2 more is n minus 4. So negative 3, subtract 2 more to get to the negative 5. So that's how we deal with the consecutives. So here's what we're going to look at. We've got to answer this question. What's the sum of 3 consecutive odd integers if the middle one is m? So we got 3 numbers, our first, our second, our third. Middle one is m. Odd or even, we have to go every other number to get the next odd or the next even. So we're going to add 2. If that were 3, to get the 5, we'd have to add 2. If that were 3, to get to the odd integer smaller, we'd have to subtract 2 to get 1. So that's the expression. What's the sum of 3 consecutive odd integers if the next to the largest one is x, or in this case, the next to the largest one is x? Well, there's only 3, so that's just another way of rephrasing 5a. We've got x, the largest one is 2 more than that, smaller one is 2 less than the original x. So there's our 3 numbers, x minus 2, x plus 2. All right, we're going to leave our consecutive numbers for a moment, and we're going to talk about comparing people in a group. 45 people in a group. Number of men is 6 less than is important, twice the number of women. So first step in the process is to choose a variable to represent the women. How about W? That we don't confuse that too much. W represents the women in this problem. All right, the next part, write an expression for the number of men in terms of the women. The number of men in terms of the women. So we're comparing the number of men is 6 less than twice the number of women. So we got to double the number of women and subtract 6 from that. Because less than means change the order of the expression in the way that the sentence is written. So instead of 6 less, which would mean 6 minus, it's 6 less than, which means we have to subtract the 6 from something. What we're subtracting it from is twice the number of the women, or 2w. So that expression is 2w minus 6. All right, an equation that describes that problem. We want to know there are 45 people in the group. If there's only men and only women, then the number of men plus the number of women must be 45. So if we add the number of men, add the number of women to get 45. The number of men was 2w minus 6. The number of women is w. That equals 45. Now this just says just write the equation and we're done with it. But let's just kind of finish this off and simplify it. 2w plus 1 more w is 3w. Now let's go ahead and solve this for w and get an answer. I'm going to add 6 to both sides, so 3w is 51, and then divide both sides by 3, and we get our answer that there are 17 women. I know it didn't ask us to find that, but while we're at it, we might as well go through and find that. You can then, if you wish, go on and try to find out how many men there were, because 2 times 17 minus 6 represents how many men there are. And I will leave that up to you. And that's today's lesson today, getting ready for word problems, changing some words into their expressions to get ready to solve word problems.